The idea that our universe is not the only one, but merely one of countless others, is one of the most mind-bending concepts in modern science. The multiverse hypothesis suggests that beyond our observable universe, there could be an infinite number of parallel realities, each with its own laws of physics, histories, and possibilities. This idea, once considered purely speculative, has gained serious attention among physicists, cosmologists, and even philosophers. But why do scientists take the multiverse seriously? The answer lies in the strange and seemingly fine-tuned nature of our own universe. The fundamental constants of physics, such as the strength of gravity, the charge of the electron, and the properties of space-time, are perfectly set for the existence of galaxies, stars, planets, and even life. If any of these constants were slightly different, our universe might be lifeless, chaotic, or even non-existent. Some scientists argue that rather than being the result of an incredible cosmic coincidence, this fine-tuning could be explained by the existence of a vast multiverse. In an infinite number of universes, some would naturally have the right conditions for life. Ours just happens to be one of them. The multiverse concept arises from several areas of physics, including cosmic inflation, quantum mechanics, string theory, and black hole physics. Some theories propose that new universes are constantly being created in a process called eternal inflation. Others suggest that every quantum event results in a branching of realities, creating an infinite number of parallel worlds. String theory, which attempts to unify all the fundamental forces of nature, implies that there may be a nearly limitless landscape of possible universes, each with different physical laws. However, the multiverse is not without controversy. If other universes exist, can we ever prove it? If they are completely separate from our own, beyond any possible observation or measurement, some critics argue that the multiverse is not a scientific theory at all, but merely a philosophical idea. Others question whether the concept of multiple realities makes sense, or whether it's just a byproduct of mathematical models that do not reflect reality. Despite these challenges, the multiverse remains one of the most exciting and provocative ideas in modern physics. If true, it would revolutionize our understanding of reality, raising deep questions about existence, free will, and the nature of consciousness. Could there be another version of you in a parallel universe making different choices? Could our universe be one of countless simulated realities? And most importantly, will we ever find solid evidence that we are not alone, not just in our galaxy, but across an infinite cosmic landscape? The idea of the multiverse did not emerge from science fiction or pure imagination. It has its roots in serious scientific theories that attempt to explain the deepest mysteries of our universe. One of the earliest hints of a multiverse came from cosmic inflation, a theory proposed in the 1980s by physicist Alan Guth. According to inflation theory, in the moments after the Big Bang, the universe expanded at an unimaginably fast rate, stretching space-time and smoothing out the cosmic structure we observe today. But some versions of inflation theory suggest that this process never truly ended. Instead, inflation continues in different regions of space, creating bubble universes that form independently of each other. If this is true, then our universe is just one bubble among countless others, each forming through its own Big Bang and possibly having completely different physical laws. Some bubbles may have similar conditions to ours, while others could be radically different, with alternate laws of physics, unique particles, or even completely unfamiliar forms of matter and energy. This concept is known as eternal inflation, and it is one of the leading scientific explanations for a multiverse. In addition to inflation theory, quantum mechanics also points toward the possibility of multiple universes. One of the most famous interpretations of quantum physics is the many worlds interpretation, first proposed by physicist Hugh Everett in 1957. According to this view, every quantum event, every time a particle takes one path instead of another, or a decision is made, results in the universe splitting into multiple versions of itself. In this scenario, every possibility actually happens in some parallel reality. Right now, there could be another version of you reading this, but in a different setting, or having made a completely different series of life choices. Another compelling multiverse idea comes from string theory, which attempts to reconcile quantum mechanics with Einstein's theory of general relativity. String theory suggests that the fundamental building blocks of the universe are not particles, but tiny vibrating strings that exist in higher dimensions beyond our perception. This theory leads to the idea of a landscape of possible universes, each with different physical laws, depending on how extra dimensions are configured. If string theory is correct, then our universe is just one possibility out of an unimaginable number of alternate realities, each shaped by different physical constants and fundamental forces. While these theories suggest that the multiverse is a serious scientific possibility, the biggest challenge remains proving its existence. If other universes are entirely separate from ours, then how could we ever observe them? Some scientists believe that subtle clues, such as anomalies in cosmic background radiation or gravitational imprints from other universes, could provide indirect evidence. Others suggest that if our universe is just one of many, we might eventually find patterns in the fundamental constants of nature that suggest a broader cosmic framework beyond our reality. The idea of a multiverse is both exhilarating and deeply unsettling. If there are infinite universes, does that mean everything that can happen actually does happen somewhere? Could there be another version of you who made different life choices, or even a universe where Earth never formed at all? As we continue to push the boundaries of physics and cosmology, the search for answers to these questions may lead us to a radical new understanding of reality, one where our universe is just a tiny part of a vast, unimaginable cosmic multiverse. One of the most fascinating implications of the multiverse theory comes from the idea of fine-tuning. The observation that our universe appears to be precisely calibrated for the existence of life. The fundamental constants of nature, such as the strength of gravity, the charge of the electron, and the ratio of the strong and weak nuclear forces, are set in such a way that they allow stars to form, planets to exist, and life to develop. If any of these values were even slightly different, our universe could be a chaotic void, a lifeless expanse, or even a place where atoms themselves could not form. This fine-tuning has long puzzled scientists and has led to the emergence of the anthropic principle, which suggests that the reason our universe appears perfectly suited for life is that we are here to observe it. In other words, the only reason we find these conditions remarkable is that if they were any different, we wouldn't exist to question them. However, many scientists find this reasoning unsatisfactory and instead turn to the multiverse as a possible explanation. If there are countless universes, each with different physical laws, then it is not surprising that at least one of them, ours, has the right conditions for life. In an infinite multiverse, every possible combination of physical constants might exist somewhere, and we simply inhabit one of the rare universes where everything aligns perfectly for life to emerge. This idea removes the need for a special explanation for why our universe is so well suited for life, replacing it with a statistical inevitability. Given enough universes, some of them will turn out to be life-friendly. However, not everyone agrees that the multiverse solves the fine-tuning problem. Some critics argue that without direct observational evidence, the multiverse remains purely speculative. Others point out that the idea of infinite universes raises philosophical and scientific dilemmas. If every possible universe exists somewhere, does that mean that every possible version of you also exists, making every decision you could have made real in some other reality? If there are infinite universes, do the laws of probability and logic even apply in the way we understand them? Despite these challenges, physicists continue to explore possible ways to test the multiverse theory. Some believe that the cosmic microwave background radiation, the faint afterglow of the Big Bang, may hold clues. If our universe has ever collided with another universe in the past, it might leave detectable scars or irregularities in this ancient radiation. Others propose that certain types of gravitational waves could carry imprints from other universes. While no definitive evidence has yet been found, the search is far from over. Whether the multiverse is a real physical entity or simply a mathematical abstraction remains one of the most profound questions in modern physics. If the multiverse exists, it would reshape our understanding of reality itself, revealing that our universe is not a singular special creation, but one of countless cosmic possibilities. The idea forces us to rethink the nature of existence, identity, and the fundamental laws that govern everything. As scientific exploration continues, we may one day find answers that confirm or refute this extraordinary idea, forever changing our perception of our place in the vast, mysterious cosmos. The idea of a multiverse is not just a question of physics. It carries profound philosophical and existential implications that challenge our deepest beliefs about reality, identity, and meaning. If we truly live in an infinite multiverse, then every possible version of events, every possible version of you, and every imaginable world must exist somewhere. This raises mind-boggling questions. Are you unique, or are there infinite versions of you making different choices in other realities? Does free will exist, or is every possible decision played out in some parallel world? One of the most unsettling ideas that comes from the multiverse hypothesis is the concept of infinite duplication. If there are infinite universes, then statistically, there must be countless copies of Earth, some nearly identical to ours and others with small or even extreme variations. There could be a version of Earth where history unfolded differently, where a different species became dominant, or where you exist but have lived a completely different life. Some philosophers and scientists argue that this challenges our sense of identity. If there are infinite versions of you, what does it even mean to be you? The multiverse also intersects with the simulation hypothesis, the idea that our reality could be an artificial simulation created by an advanced intelligence. Some scientists and philosophers, including Nick Bostrom, have argued that if it's possible to create such simulations, then it's likely that simulated worlds vastly outnumber base reality, meaning that we may already be living inside one. Beyond identity and simulation, the multiverse theory also challenges traditional religious and metaphysical perspectives. Many religious and philosophical traditions are built around the idea of a single, unique creation, with our universe being the only one in existence. If the multiverse is real, then there could be infinite versions of creation, infinite versions of different physical laws, and even infinite versions of life itself. This raises profound questions about the nature of consciousness, the soul, and the meaning of existence in a reality where there are no absolute boundaries between worlds. Despite these philosophical challenges, the multiverse is an idea that continues to push the boundaries of human thought. Whether or not we can ever prove its existence, it forces us to rethink everything we believe about reality. Is our universe just one of many? If so, what does that mean for our understanding of life, existence, and the choices we make? As science advances, new discoveries may bring us closer to answering these questions. Perhaps future breakthroughs in cosmology, quantum physics, and artificial intelligence will provide evidence that confirms or refutes the multiverse. Until then, the idea remains one of the most thrilling and unsettling possibilities in modern science, one that challenges us to confront the true vastness of reality and our place within it. The search for evidence of the multiverse remains one of the greatest challenges in modern science. While the idea is supported by theories such as cosmic inflation, quantum mechanics, and string theory, direct proof remains elusive. Unlike planets, stars or galaxies, which we can observe with telescopes, other universes, if they exist, may be fundamentally inaccessible to us. However, that hasn't stopped scientists from looking for possible clues that could indirectly confirm the existence of a multiverse. One of the most promising areas of investigation is the cosmic microwave background radiation, the faint afterglow of the Big Bang. Some physicists propose that if our universe has interacted with another universe in the past, perhaps through a collision between bubble universes, then it might leave detectable patterns or anomalies in the CMB. Researchers have already found some unexplained irregularities in this radiation, but so far no definitive evidence of another universe has been confirmed. Another potential clue could come from gravitational waves, ripples in space-time caused by massive cosmic events. If another universe had ever influenced our own, the effects might be encoded in these waves. Future advances in gravitational wave detection, using observatories such as LIGO and the European Space Agency's planned LISA mission, could provide insights into whether our universe has been shaped by external forces beyond its own boundaries. Some scientists also speculate that the fundamental constants of physics could offer hints of a multiverse. If we were to discover that certain physical constants vary in distant regions of the cosmos, it could suggest that different parts of the universe, or different universes altogether, operate under different rules. So far, however, every measurement we've made of these constants shows that they remain the same everywhere we look. Even if we never directly detect another universe, some physicists argue that the multiverse could still be considered a valid scientific explanation if it helps solve major mysteries in physics, such as why our universe appears so finely tuned for life. Others remain skeptical, insisting that without testable predictions, the multiverse remains more of a philosophical idea than a scientific theory. The multiverse theory, whether viewed through the lens of cosmic inflation, quantum mechanics, or string theory, challenges everything we thought we knew about reality. If true, it would mean that our universe is just one of countless others, each with its own unique physical laws, histories, and possibilities. This idea, though mind-boggling, provides potential answers to some of the biggest mysteries in science: why the universe seems fine-tuned for life, why quantum mechanics appears to allow multiple outcomes, and why we may never fully understand the ultimate nature of existence. Yet, despite its scientific appeal, the multiverse remains speculative. Without direct observational evidence, it sits at the edge of what can be considered a testable scientific theory. Some physicists argue that the multiverse is a necessary consequence of our best current models, while others caution that it may never be provable in the traditional sense. The search for evidence continues, whether through anomalies in the cosmic microwave background, gravitational waves, or deeper insights into quantum mechanics. Beyond science, the multiverse also forces us to reconsider existential and philosophical questions. If there are infinite versions of you, what does that mean for free will? If every possible universe exists, do our choices truly matter? And if we are just one of countless realities, how do we define meaning in our lives? These are questions that stretch beyond physics and into the very core of human thought. Despite the lack of direct evidence, scientists continue to explore potential ways to test the multiverse hypothesis, whether through analyzing cosmic radiation, detecting gravitational wave anomalies, or further refining quantum mechanics. The quest to uncover the true nature of reality is far from over. The debate over the multiverse is not just about science. It is about the limits of human knowledge and our ability to comprehend the vastness of existence. If we one day find proof of other universes, it would be one of the greatest discoveries in history, one that would alter our understanding of physics, reality, and ourselves. Until then, the multiverse remains a compelling possibility, an idea that pushes us to think beyond what we know and imagine the unimaginable. Whether or not we ever confirm its existence, the journey to explore this concept has already expanded the horizons of science and philosophy, inspiring us to question the very nature of the cosmos and our place within it. The idea of the multiverse forces us to confront the most profound mysteries of existence. Is our reality unique, or are there countless variations of it? Are we the product of a cosmic accident, or do infinite versions of us exist in different worlds? If every possible universe exists, what does that mean for free will, identity, and meaning itself? These questions may remain unanswered for generations, but the search for truth continues. Whether through advancements in quantum mechanics, deeper observations of cosmic radiation, or breakthroughs in theoretical physics, humanity will keep pushing the boundaries of knowledge. The multiverse, if real, could be the key to unlocking the deepest secrets of reality. But even if we never find definitive proof, the pursuit itself drives progress, inspiring us to question, to explore, and to imagine the unimaginable. For now, we stand at the edge of the unknown, looking out into the vast cosmos, wondering if somewhere beyond the limits of our perception, other universes await discovery. Whether we are alone or part of an infinite multiverse, one thing is certain: our journey to understand existence is far from over. With every scientific breakthrough, we take one step closer to uncovering the true nature of our universe, or perhaps the multiverse. Whether through deeper explorations of cosmic radiation, experiments in quantum mechanics, or theoretical advancements in string theory, the search for other universes is far from over. Even if the multiverse remains beyond our grasp, its implications have already transformed the way we think about existence. If the multiverse exists, it could mean that every possible version of reality has played out somewhere, that every choice we make is just one of infinite possibilities, unfolding across countless dimensions. It could mean that our universe, vast and mysterious as it seems, is just a single drop in an endless cosmic ocean. But even if we never find concrete evidence, the questions the multiverse raises are just as important as the answers. They push the boundaries of science, philosophy, and human imagination, challenging us to rethink everything we know about reality. Whether we live in a lone universe or one of many, our search for understanding continues, reminding us that the greatest mysteries are the ones that inspire us to keep exploring. So, the pursuit of the multiverse is not just a scientific endeavor, it is a testament to humanity's unyielding curiosity. Whether we ultimately prove or disprove its existence, the journey itself pushes the frontiers of physics, expands our philosophical understanding, and forces us to confront the fundamental nature of reality. The possibility of a multiverse challenges our perception of uniqueness, fate, and even the meaning of existence. If we are indeed part of an infinite cosmic network, it would reshape not only our understanding of the universe, but also our place within it. The knowledge that countless other realities could exist, perhaps with versions of ourselves living out different lives, may feel overwhelming, yet it also offers a humbling perspective. It reminds us that in the grand scale of existence, we are part of something far greater than we can yet comprehend. Until the day we uncover definitive proof, the multiverse remains one of the most fascinating and perplexing ideas ever conceived. Whether reality is singular or infinite, one thing is certain: our quest to understand the cosmos will never cease. The unknown beckons, and as long as we continue to explore, question, and seek the truth, the universe, whether one or many, will remain full of possibilities.